Welcome to the second section of this course. This section is entitled Getting Deeper with Elasticsearch. In this section, we're going to take a look at the ins and outs of Elasticsearch. We'll look at how we store and group data using documents. We'll specify some document attributes. We'll classify similar documents using type. We'll organize and group documents together with indices. And then we'll dive into getting your data back. We'll look at the huge suite of tools available for Elasticsearch search. In this first video, we'll look at how we store and group data into documents. We'll take a look at what a document is. We'll rehash some of the information that we've covered before. Then we'll look at the APIs and how we can put a document into Elasticsearch. We'll relate documents together. And then we'll talk about document IDs and document versioning. And then the fun part, we'll talk about why none of that or not much of that really matters, since there's a way you'll be loading your data most likely. All right, let's start talking about a document. So, document in Elasticsearch is the thing that you're representing. It's the card, the person, the song, the log entry from a log file. It's the thing. It's the aggregation or the different pieces of data attributes that are, when combined, make one document. These pieces of data are called attributes. So they're a string name, so first name, last name, age, date of birth, anything like that. Message, some classification data, anything like that is an attribute. If you think about a key-value pair, like in a Redis database or some other database, a key-value pair is how we define the attributes within a document. So the values we have are what we're going to talk about for a little bit here. They have types. So like any relational database or any other database you're probably familiar with, programming languages, etc., all variables have types. So you can have integers, strings, different types of numbers like floats and doubles, longs. You can get into characters, strings. Elasticsearch has a keyword attribute we'll get into and see where we can use that. You can also get into items like geographical information, geopoints or geoshapes, so you can draw boxes around places on a map. So let's get into some of that. Let's start with the document API. Elasticsearch comes with a full-fledged RESTful API, well-defined on their website. If you go to elastic.co and find all the API documentation for Elasticsearch, it's all there. So make sure you're looking at the Elasticsearch 6 to follow along in this video. But like most databases, Elasticsearch has the full suite of CRUD: creating, reading, updating, and deleting data. For Elasticsearch, you can create using the put in the post APIs, and we'll get into those in a minute. You can update the data that's already there, and that's where we'll talk about versioning. You can also delete records, as well as read data using queries or using just regular RESTful GET using object IDs. So let's start diving into this create API. So with the create, you can create objects or create documents within Elasticsearch. One thing to note is that you can give or provide an ID, a unique identifier for each document within an index, and a type. We haven't really talked about indexes or types yet, but we'll get into those. But they're important to know. That's how we organize data. So every piece of data is indexed, which is a grouping of a whole bunch of different documents. Those documents all have a type. A type can be something like a car or a person, like we talked. And then each document has an ID, whether you provide it or not. These IDs must be unique within Elasticsearch. So let's look at these, and we'll jump over to some code in a second to show you how this runs. So if we look at the HTTP put, we can provide an ID for the document in the form of HTTP host and port / the index name / the type and / the ID. And then the body of this HTTP put will be a JSON object representing them. So you can see at the example below, I have a curl command that you can run in your browser if you have Elasticsearch installed at local curl -X put that tells it to use the put method of HTTP. We pass the URL saying localhost :9200, which is the default port for Elasticsearch, / cars for sale. Cars for sale is the index, / car is the type, /1. We're going to add a document with the ID of 1 in the car type within the cars for sale index. So here we can see the user attribute at the bottom is Fowie. The post date, or the date we're adding it to the database, was in 2009, November 15th. The make is a forward and the model is a flex. So let's see that run. So if we look over here in our shell script, I'll show you the shell script for the create.sh. It's exactly the curl command that we showed in the slide over there. So when we run this, you'll see the output from Elasticsearch. It says it was created in the index cars for sale, type of car, ID is 1, version is 1. The result of the API command was created, and we'll talk about shards later. And you can see that that document was created. Now let's create an object without a provided ID. So again, we'll look at this create_noid.sh file, which will be available to you in the code repository after the course. You'll run curl post again, cars for sale index with the car type, and then we'll, with no added ID here. Again, we'll pass a car with a user of Fawi, post dated 2009, November 15th. This is a Nissan Sentra. So I'll show you what happens when we create with no ID. Now here, look, the document was created in the cars for sale index, the type of car, and a very unique looking ID. So in this case, the ID was created by Elasticsearch because every document needs a unique identifier. All right, let's move on to reading this data. So we know we have a car with the ID of 1 in the cars for sale. I'll show you now how we can run HTTP GET following the standard RESTful pattern of using GET to retrieve data. The get.sh script just executes curl, which is a web client if you weren't familiar, an HTTP curl get localhost cars for sale car/1. So we'll execute that, and we'll get our forward flex. Now here's a fun one. Since I grabbed that ID that was created by Elasticsearch for the other car, let's see what happens. Now we'll look at updating. So updating is how we can set versions on here. Whenever we want to update a document, it's very much like the creation with the ID, but if the ID is already existing, it'll just update the document. So here we can see there's a minor change to the model of the car. It's a Ford Flex SEL. I think that's better than the Ford Flex, but what do I know? So we will run another curl command, putting the same index cars for sale car/1 for the car with the ID of 1. Same user, same post date, same make, but a different model. So you can also add a version parameter for what they call optimistic concurrency control. This allows you to tell Elasticsearch, I know you have version 1 in the database. So when I make this put, I'm going to pass in version 1. If somebody else has updated it to version 2 already, or version 3, 4, 5, then my HTTP put will fail. It will only update what I expect it to update. It's just something to know when you go and use these APIs in your own application. So here, we'll run the update script, which runs that curl command that we looked at before. And we'll see the index cars for sale, type car, ID. It's the same ID because it's the same document we're updating, but now we have version 2. We can see that it was updated instead of created, just like we expected it to. Now we can delete the car. It's as you would expect. Curl command using the HTTP delete. And again, you need to pass in the index, the type, and the ID. So let's run that. You'll see it's a curl delete. And Elasticsearch will give us the metadata on the return that says it was in the index cars for sale, which is what we passed in. Type car, ID 1, version 3. Result was deleted. So now when we go and run that get command again, what do you think will happen? Found is false. There is no car with the ID of 1. Okay, and here's why none of that inserting and updating stuff matters. If you're dealing with an application where you're building a data store for, say, search on a website, versioning might matter. You might run a script that says, every time somebody posts a new blog post or posts a new article or posts a new comment on something, then I'll insert it into Elasticsearch so it can be read. But I think the majority of people using Elasticsearch are using it for the logging use case, where they'll start collecting data over time, and they'll just pull in a lot of data. They'll take, server logs from 15, 30, 100 computers, and bring it back into one central Elasticsearch location so they can use Kibana to search it and find out all the things happening across their network. That's great. But they're not going to be writing a script that inserts every line, one line at a time, of every log file they want to collect from every server they want to collect. First off, it's extremely inefficient. Posting just one document at a time is really slow. So in a real-world logging use case, you'll end up getting thousands of lines, thousands of documents per minute, per second even, into a single index. So the way you would run it is every day you have a day-based index for your logs. Then at the end of a time period, say you want to store your logs for 30 days, over 30 days old data you'll delete. And instead of deleting them by individual documents, you'll just drop a whole index. That's the most efficient way to drop a whole lot of data. You're never going to update your history. History does not change. So for a network forensics standpoint, for instance, or a computer history, or for the history of a computer, you want to know exactly who logged in at what time onto the computer. And you never want that to change. You don't want to go in and update that document. So all you're going to be doing probably is using the bulk API, which means I can give Elasticsearch one command, maybe with 3,000 documents to index at one time. And the turnaround time for Elasticsearch to index that 3,000 is very, very similar to indexing one document, but you just saved a HTTP request 3,000 times. So the time for that network latency is saved. So what we're going to do here, I'm going to show you an example. So the bulk API is a little different than the regular document APIs. Here you can see we have the same local host, but we have this new endpoint called _bulk. This means I'm going to give bulk or a long list of commands for Elasticsearch. It's not only inserts, we can also update, we can also delete, but you'll primarily see it as the indexing endpoint. So here you can see it's a multi-line file. So you'll see all these lines are not one valid JSON object. It's actually 1, 2, 3, 4, 5, 6 lines. Each line is its own valid JSON object, followed by a new line character. So you'll see the first command I'm saying is index this document of type car in the index of cars for sale. So again, index this document in the index cars for sale with a type of car. And then the next line is the car. So again, a Nissan Sentra. After that, we're going to index in the same cars for sale index, in the same type of car, another document, a Jeep Wrangler. Then we're going to insert a Honda Santa Fe Sport. So we can issue that as all one curl command. So I'll show you what happens when we do that. All right, that scrolled by quickly. So I'll go up to the top to see what happened. So you'll see it took 4 milliseconds to insert 3 documents, which is great. There were no errors, so you'll see this top level attribute of the return value is an errors value. Here it'll be a true or false, it's a Boolean. Typically, if you're writing code to use a bulk indexing APIs like I do, you'll basically look for a true value here for the errors. If it's not true, all is good, move on. So you'll see, and then it returned a list of the items that it indexed. These look like the results of the indexing API we looked at earlier. It tells you what index, what type, the ID, the version, and what happened to the document. So all of ours were created with a status of 201. That happened for all of them. So we just created 3 cars with one bulk API insert. In our next video, we'll look at specifying document attributes by using different data types to solve for different problems.